Hey guys, welcome to my next video. Today I'm going to be going over question number 13 from chapter 3 of the Chemistry Kaplan book. Which of the following is the best name for the new bond formed in the reaction shown? And then we're given a list of bonds to choose from. In this reaction we have water, which is H2O, reacting with a hydrogen ion to form the hydronium ion. And remember, one of the cool properties about water is that when it's in the presence of an acid, such as the hydrogen ion, it's going to act as a base. And that's exactly what happens in this reaction. Water is proton accepting, and so it's going to form a bond with hydrogen, and it's going to accept that hydrogen atom, or proton, and it's going to form the hydronium ion. And so that's what's happening in this reaction here. Water is a base, hydrogen ion acts as an acid, and we form the hydronium ion. So which of the following is the best name for the new bond formed? Well, let's start off with A, nonpolar covalent bond. This is going to be false, and I'll show you why. These are the bonds formed in the reaction shown. We have 3 hydrogen atoms bonded to a single oxygen atom. And these bonds right here are actually polar. They're covalent bonds, but they're polar. And that's because there's a huge electronegativity difference between oxygen and hydrogen. So let's draw one of those bonds here. In actuality, there's 3 of these. Now, oxygen has an electronegativity about 3.4, while hydrogen has an electronegativity of about 2.2. And so there's a huge difference in electronegativity here. It's about 1.2. And usually whenever there's an electronegativity difference that's higher than 0.5, we're going to classify that bond as polar. And so that means this oxygen atom is going to bear a partial negative charge. Meanwhile, this hydrogen atom is going to bear a partial positive charge. So A is not true because this is a polar covalent bond. Okay, let's move on to B. Ionic bond. This is also not true. And the reason why this is not true is because, remember, ionic bonds are bonds between an, a gas and a metal. And here, hydrogen and oxygen are both gases. They're not metals. So this is not an ionic bond. Also, we established that this is a covalent bond. And that's because of this bond right here. These electrons right here are being shared by both atoms. And the fact that they're being shared by both atoms is a characteristic of a covalent bond. So B is not true. C, coordinate covalent bond. So this is actually our right answer. But before I actually explain why it's a coordinate covalent bond, let me explain why it's not the hydrogen bond. So although this bond right here is actually an example of hydrogen bonding, coordinate covalent bond describes this reaction, the bonds formed in this reaction a lot better. And the reason why this is a hydrogen bond is because hydrogen is bonded to one of these 3 atoms. Oxygen. I don't know why that popped up as a diamond. Okay, so we have oxygen, fluorine, and nitrogen. Typically whenever hydrogen is bonded to any of these 3 atoms, it is a hydrogen bond because these atoms are very electronegative. And that's actually what we see here. Hydrogen bonded to oxygen. But coordinate covalent bond is a more specific and better way of classifying the bond formed in this reaction, and I'll show you why right now. Let me just erase this real quick. So in acid-base chemistry, coordinate covalent bonds are very apparent. And that's what we have here. Remember we said that water is a base and hydrogen is going to act as an acid to form the hydronium ion. A coordinate covalent bond is formed because of these two hidden lone pairs of electrons that are not shown here. But I'm going to draw that here. So we have water, and water has a bent structure. And the reason why it has a bent structure is because of two lone pairs of electrons. And we'll draw those in blue. And when it reacts with this hydrogen ion, which I'm going to draw here, water uses two of its own electrons to form this bond here in order to yield the hydronium ion. Oh, not sure what happened there. Okay. To form the hydronium ion, which I'm going to draw right here. And then it's left with one lone pair of electrons because it's using one of them to form the bond. And the fact that water is using its own pair of electrons to form this bond means that this is a coordinate covalent bond. Hydrogen is not using any of its electrons to form this bond. It's not contributing any electrons to the new bond being formed because it has no electrons. Remember, hydrogen ions are simply just protons, just a single proton. So this hydrogen ion is lacking electrons. And so this is why it's a coordinate covalent bond. Alright guys, hope this video helped you out. If you like the content, go ahead and leave a like and maybe even subscribe, and I'll see you guys next time. Thank you.